No way. This is not coming from a physics department. That's just wrong. Newton would be rolling over in his grave. Welcome to the Physics Almanac. Today I'm going to be reviewing 3 physics shorts a friend of mine sent me. They appear to all be discussing orbital motion based on their titles. The first one's called Why We See a Micromoon versus a Supermoon. This is by TAMU Physics and Astronomy, which is Texas A&M. The next one's called Earth's Orbit Around the Sun with Neil deGrasse Tyson. And the last one's called The Sun Actually Orbits the Earth! Exclamation point! By someone named, or the channel name at least, is Alex O'Connor. I don't actually know who the speaker is. That's the one I'm most curious about, but we're going to save that one for last. We're going to start off with why we see a micromoon versus a supermoon. Now, I have a pretty good idea what this is about. There's one of 2 possible effects it could be discussing. We'll see which one it is. Before we get started, please be sure to hit those like and subscribe buttons. And without further ado, here we go.
Did y'all know that the moon doesn't actually orbit the Earth?
Oh no, not one of these. Now I know why my friend sent me this. This is a pet peeve of mine that astronomers say this. To be fair, she hasn't actually said it yet. But she's gonna say it. There's no other way the sentence ends. Alright, here we go.
Oh no, the mass of the Earth and the moon orbit the common center of mass.
There it is. Have astronomers not taken intro physics, like literally the first thing you learn on the first day of physics? Newton would be rolling over in his grave if he knew that this is what was being said based off of his equations. If you don't know anything about physics, that's fine. You don't need to, but just know this one thing that'll put you at the latest 1500, the year 1500. Motion is relative. There is no such thing as absolute motion. Who's moving and who's at rest is entire matter of point of view. Yeah, you can say that the moon and the Earth orbit the common center of mass. That's perfectly fine from the point of view of the common center of mass, or even maybe like the sun or some other external point. But don't say that the moon doesn't orbit the Earth, because from the point of view of the Earth, that's exactly what happens. Because the Earth is at rest relative to itself. So it just sees the moon go around it. And likewise, you could take the point of view of the moon, and the moon is now at rest relative to itself, and it's going to see the Earth go around it. They're all perfectly valid points of view. The center of mass point of view is not a special one. It's special to us because it turns out mathematically it's generally easier to solve from the center of mass point of view. But that's just a human choice. That's not some universal idea that the center of mass is a special reference frame. You can pick any reference frame you want. They're all equally valid. Wait, I thought this was about supermoon micromoon effect. What does that have to do with the barycenter? Well, maybe she'll get to it.
The barycenter. My bowling ball represents the mass of the Earth. The small mass on the side represents the moon. The Earth is 81 times the mass of the moon. Let's go ahead and give this a spin. So we let our system go. Notice that the off-center moon mass is now drawing the entire system to wobble. This is truly what happens with our Earth-Moon system. The barycenter.
Okay, it's not truly what happens with our Earth-Moon system. It's what happens from a specific point of view, from the point of view of the center of mass. Here, let me go back to this image here. So on this bottom one, it wasn't wobbling because the center of mass is at the center of the ball. On the top one, the center of mass is offset, so both move, but that's from the point of view of a reference frame that's stationary relative to the center of mass. You could just as well pick the point of view of the big ball, in which case now the big ball is at rest relative to itself. And it's just going to say, the little ball's going around me. I'm not wobbling. I don't move relative to myself. Or you could take the point of view of the little ball, and now the little ball is at rest, and it's going to say that the big ball's going around it. They're all equally valid points of view. Right? There's nothing in Newton's equations that says this object's moving and this one's at rest, or they're both moving relative to some third point. That's a choice you make. If you do orbital motion with Newton's equations for two-body system, you're going to get 2 things. First thing you're going to get is the motion of the entire system, so the center of mass motion. and you'll find that that moves at a constant velocity, assuming you're in an inertial frame, a frame that's not accelerating. If you want to be an accelerating frame, that's fine too. You just have to correct Newton's equations because Newton's equations are written from the point of view of an inertial frame. But Newton was perfectly aware that that's not some universal special frame. He just wrote his equations from that point of view. You can modify them and view the world from an accelerating frame if you want. The second thing the two-body system is going to get you is the relative motion of the two objects. All right? But you can pick one of those objects to be at rest. And that's perfectly fine. There's nowhere where it says this object's moving, this one isn't. It's all relative. Now let's continue.
With our Earth-Moon system, the barycenter is in our mantle, not truly the core of Earth, far below the crust, but above the true Earth's core in Earth's mantle.
Okay.
Now,
Right,
since
so it's
the
offset.
orbit is not perfectly circular, the
Okay,
orbit
here we
of
go.
the moon about the Earth is not always constant. That means
The orbit of the moon about the Earth is not always constant. I think she means the radius is not constant. It's still the same orbit unless something like disturbs it. But the radius, the distance is not constant. And wait a minute. Did she say the orbit of... Hold on, let me go back here a second.
the
Let's listen.
orbit is not perfectly circular. The orbit of the moon about the Earth
The orbit of the moon about what? It's written right on the screen. About the Earth. So now she is taking the point of view of the Earth. So she's perfectly willing to take that point of view and accept that that's a valid point of view. But I guess she hasn't connected the dots that doesn't match her initial statement that the moon does not orbit the Earth. It's fine to say the moon doesn't orbit the Earth from a specific point of view. You got to qualify it with that. And it's fine to say that it orbits the center of mass. That's also from a specific point of view. Now, I don't mean to pick on her. I don't know this woman. For all I know, she's just an actress reading a script. But yeah, motion is relative. That's the only thing you got to know.
is not always constant. That means that sometimes the moon is a little bit closer and sometimes it's a little bit further
Right.
away. During its furthest point away in the eccentric orbit, we have a micromoon up in the sky. When it's a little bit closer during a full moon, we get to view a supermoon. Did y'all know that the
Right, so it's pretty straightforward. That's the end of the video. When the moon's closer, it looks bigger. And when it's further away, it looks smaller. And when the closest point happens to line up with the full moon, you get a supermoon. And conversely, when the furthest point happens to line up with the full moon, you get a micromoon. But again, who's moving and who's at rest is relative. Maybe this is a student channel. Maybe she's a student. She doesn't look like an undergrad. She could be a grad student, but grad student should know better, really. Even an undergrad should know better. Let's see. Is this a student channel? Can you have a student channel like with the name Texas A&M associated to it? Are you allowed to do that? I don't think you would be allowed to do that. Let's see what they say. The moon orbits Earth in an oval-shaped path called elliptical orbit, so it's not always the same distance from us. Sometimes it's closer. This is called perigee. Well, that's the closest point. Other times it's further away. That's apogee, the furthest point. A supermoon happens when the moon is full. They're capitalizing moon. Are you supposed to capitalize moon? I don't capitalize moon. Let me know in the comments. Do you capitalize moon? Is that grammatically correct? A supermoon happens when the moon is full and at its closest point to Earth, making it look bigger and brighter in the sky. A micromoon, on the other hand, is a full moon at its furthest point, so it looks smaller and dimmer. Yeah, I 100% agree with everything there. But that's got nothing to do with the barycenter. That's just relative distance. The reason the moon's distance changes is because both Earth and moon orbit around a shared center of gravity called the barycenter. No, that's not why it changes. Wait, am I missing something? No, that's just a point of view. The reason the distance changes is because it's not a circular orbit. If you had a circular orbit, even if you're viewing it from the point of view of the center of mass, So now both are orbiting the center of mass frame, or the center of mass, and it's a circular orbit. The distance, the relative distance between the Earth and Moon doesn't change. So the Moon never gets bigger or smaller. It's always the same distance, so it's always the same size in the sky. It's irrelevant that they're going around the common center of mass. And likewise, if you took the point of view of the Earth, if it's a circular orbit, it just sees the Moon at the same distance, never gets smaller or bigger. It's irrelevant that you're at from the Earth's point of view or from the common center of mass point of view. That's just wrong. I mean, you can give them a pass on the claim that the Moon doesn't orbit the Earth, because from a certain point of view, that's correct. You just have to specify you're taking in the world from that point of view. That's really, it's a minor inaccuracy. That's kind of a pet peeve of mine. But this is just wrong. It's got nothing to do with the center of mass frame. It's entirely because it's an elliptical orbit, so the radius is not fixed. This wobble in their movement combined with Moon's elliptical orbit creates this variation. No, it's only the elliptical orbit. All right? If you have a circular orbit, distance is constant. So the size of the Moon parent size of the Moon doesn't change. It's always at the same distance from you. When a full moon lines up with perigee or apogee, we get either a supermoon, right? Okay, that's correct, but this has to be a student channel. There's no way this is coming from the physics department. The presenter in this demo is Dr. Alison McGraw from @TAMU. This is a professor. Maybe she's just a researcher, not a professor, but still, you have a PhD and you're saying this? Maybe she didn't write this description. But still, if this is the physics and astronomy department, come on. No way. This is not coming from a physics department. You know, when I was an undergrad, we used to have a joke that astronomers were just failed physicists. It was a joke. We didn't actually believe it. Half the people in our classes were astronomy majors. We had all the same classes. There's really no difference between an astronomer and a physicist. It was just a joke. But, you know, when you hear this sort of thing, you kind of have to wonder if there's not maybe a little truth to that joke. Although this is physics and astronomy department, so she might be in physics. I'm guessing she's in astronomy. But still, okay, Dr. Alison McGraw, I'm willing to admit I'm wrong. All right, show me where in Newton's equation it says who's moving and who's at rest. Show me that. If you can show me that, I'll admit I'm wrong and that the Earth does not orbit the Moon from any point of view. Or the Moon does not orbit the Earth from any point of view. Either way. But that's a point of view. The main problem here is you're saying that because they orbit the barycenter, that's why you get supermoon, micromoon effect. That's just wrong. Okay? I'm 99% sure that's wrong. But if you want to prove me wrong, I'll happily admit I'm wrong. I'm not here to say I'm wrong, I'm right. I mean, I just like to know what's true. That's the point of view of a physicist. We just want to know the truth. We don't care if it's right or wrong. Well, we can go on to the next video, although I think we'll skip this one. I would say if you're going to study physics and astronomy, don't go to Texas A&M. So let's do the next videos. This is already pretty long, so let's do the next videos another. Oh, does this mean that Neil deGrasse Tyson said the same thing? Oh, not Neil. Come on, man. I like Neil. Well, I guess we'll find out. Well, if you want to see me react to Neil deGrasse Tyson's video, Earth's orbit around the sun, and the next one, the sun actually orbits the Earth, be sure to like and subscribe and hit the notification bell to be notified for those videos. And if you'd like to support the channel, you can go to my Ko-fi page. There'll be a link after the video, and you can also find it in the description. Let me know what you thought of this video in the comments. Do you think I'm right? Do you think, what's her name? Dr. Alison McGraw is right? Or are we both wrong, maybe? Let me know what you think, and I'll see you in the next one.